The following video is for informational purposes only. It is simply the opinion and experience of myself regarding solar. It is not meant to be investment or tax advice. I am not an electrician. I am not and have never been in the solar industry. I am not being compensated by anyone to promote any products. It is always best to consult an expert before making any decisions regarding investments, taxes, and solar. In this video, I want to talk about my system. But before I talk about my system, it's important to understand the goals that I have for my system. Number one, I wanted to zero out my electric bill. So I wanted to have no electric bill, no monthly electric bill. Number two, I wanted to send as much clean energy as I can back to the grid. I would consider that my contribution to the grid. And number three, I want to have a whole home clean energy backup system. So if the power goes out, my house will run normally. So those are the three goals. So with those in mind, let's take a look at my system. I started my solar buying process in early 2020. My system became operational on September 12, 2020. As you can see, it is 9.45 DC direct current or 7.2 AC alternating current. It consists of 30 315 watt solar panels. We arrive at 9.45 kilowatts by multiplying 315 watts by the 30 panels. The DC to AC conversion factor for my system is 1.3125. Solar panels produce direct current. Our homes use alternating current. Therefore, the direct current must be converted to alternating current before a home can use the electricity. This is what the inverters do. As you can see, my system has 30 inverters, one for each solar panel. I have a standing seam metal roof, therefore the panels are mounted using clamps on the seams. My panels are arranged in 4 arrays, 2 facing due south and 2 facing due west. I have 12 panels facing south and 18 facing west. In early 2021, I started the process of purchasing a solar battery for whole home backup. I initially had a contract for 2 Tesla Powerwalls, but due to demand and them being battery constrained, I discovered it would be 6 to 8 more months after waiting for 6 months. As it turned out, I believe I decided on a better choice. I purchased 3 Enphase IQ10 batteries. It makes sense to get a battery from the same manufacturer as my solar microinverters on my roof. It all works seamlessly and can all be controlled through one app. Each IQ10 consists of 3 IQ3s. Therefore, there are 9 IQ3s in my system. Each IQ3 has 4 microinverters, or 36 for my total system. This provides redundancy should any microinverter or battery go down. My battery can store 30.24 kilowatt hours of energy and provide 11.52 kilowatts of power. So before we go any further, it's important to understand the difference between power and energy. Power is the rate at which electricity is flowing, whereas energy is the amount of electricity that has been consumed over a given period of time. So you'll always see a time factor in the units of measure. It's measured in kilowatt hours. So energy is always going to be measured in kilowatt hours or watt hours. You always have a time factor in there. Whereas power would just be measured in kilowatts or watts. So for example, let's say I turn on an appliance. And as I turn on that appliance, it is consuming 1 kilowatt. So if it's consuming 1 kilowatt, that is the power that appliance is putting out. So over 1 hour, it would have consumed 1 kilowatt hour. So that is the energy that appliance has put out over that time. So these are terms I'm going to be using from this point forward, so it's important to understand. It's also very important to understand these terms if you're thinking about purchasing a battery, because these two terms are very important and you need to understand them for that purpose. Now let's look at the data from my system. The first full year I had solar was 2021. The first full year I had solar and batteries was 2022. So we'll look at these 2 years. All of this data is coming from my Enphase app. We're looking at my home energy totals for 2021. You can see my house consumed a little under 8.4 megawatt hours of energy in 2021. Now, a megawatt hour is 1,000 kilowatt hours. You can see my solar production was 14.5 megawatt hours. And if you subtract the 14.5 minus the 8.394, we get 6.173 megawatt hours net solar production. That's how much clean energy I sent back to the grid for others to use in 2021. Here we're looking at my home energy totals for 2022. My house consumed a little bit more than 8 megawatt hours in 2022. And then if you look, you can see that the battery actually consumed almost 1 megawatt hour. Now the battery consumes energy because it has to maintain its charge, and the solar maintains the battery's charge. So you can see it does add to my consumption. For my solar production, I produced, again, 14.5 megawatt hours of energy. So if you subtract 14.521 minus the 0.997 minus the 8.088, we come up with 5.436 for my net solar production. So again, that's how much clean energy I sent back to the grid. So 5.436 megawatt hours of energy back to the grid for others to use. In case you're wondering, and if you're curious, if I didn't have the battery, I would have sent back 6.4 megawatt hours of clean energy back to the grid. I like that battery. I like the backup capabilities of my battery, so that's a small price. So now we're looking at the home energy data by month for 2021, and you can see here how my solar production goes up as the summer months come about, and then it goes back down as the winter months come back down. So we'll get this curve that you'll see this yearly curve, and it's very common for all solar systems. You'll see the curve that it will go up. The solar production will go up in the summertime because the days are longer and the sun is higher in the sky. So you're going to produce more solar in June, July, and August for these months. And in the winter months, January, February, and December, we're not going to produce as much because the day is shorter and the sun is lower in the sky. So the solar is going to go up as the year goes on until about July and August, and then it'll start going back down. For the consumption, you'll see a similar curve, and it looks like, and you can see, you can kind of use your imagination there, but the curve looks kind of like that. And you'll see the consumption goes up also in the summer months, June, July, and August, because I'm using more AC or more air conditioning. In Corpus Christi, it gets very hot in the summertime, so we're going to use more energy in the summer months than I will in the winter months. We don't really get that cold in the winter, and I have another way to mitigate using my my heater, which I'll talk about in a future video. But this is a typical curve for consumption and production curve. So you can see production goes up, consumption goes up, and then as the summer turns into fall and then winter, both the solar production and the consumption go down. So here's the monthly data for the year 2022, and you can see the curve is similar. You can see for the solar production, as the days get longer, I start producing more solar, and you can see here in the summer months that's what happens, and then it comes back down, very similar to the curve that we saw for 2021. And if we look at the consumption curve, it's very similar. Now I've added the battery consumption to this here in this stack bar chart, so it's a little bit different. The chart looks a little bit different than the 2021 chart. But you can see the curve is still the same for the consumption, not necessarily the battery consumption, but just the general consumption it goes up in the summertime and then goes back down in the winter and fall months. So you can see, again, very similar to the curve that we saw in the for 2021. So this is typical for any solar for any year. You'll see this very similar pattern. We're looking at the net solar production for 2021. So this is the solar production minus my consumption. And you can see every single month in the year of 2021, I produced more solar than my home consumed. And so this is the extra amount of clean energy I sent back to the grid. You can see even that cold month of February. Remember when we had that big cold snap? Those of you who were in Corpus Christi at the time, or even in Texas at the time, remember that huge cold snap that we had where the power went out. Fortunately, my power didn't go out, but it was very cold. And I still produced more solar than my home consumed. And you can see the months of March, April, and May, the spring months. Those are the best for net solar production, and it's because the sun is higher in the sky at that time, or starting to get higher in the sky at that time, and it's not as hot as it gets in the summer months. So I'm not running the AC as much, and we're getting a lot of sun. So that is ideal for net solar production. I'm producing a lot of solar, and I'm not consuming a lot of energy. And you can see in the winter months, it's the opposite. So this is the data for 2021. Here is my net solar production for 2022, and you can see it's a little bit lower, even though I produced more solar every single month than my house consumed. It is a little bit lower because of my battery consumption. My battery started consuming energy. That this is the first full year that I had my battery, but you can still see that I produced more solar every single month than my house consumed. And you can also see the months of March, April, and May were the highest for net solar production for, again, the same reason. So am I accomplishing my goals? Well, let's review my goals. Number one was to eliminate my monthly electric bill. Now, we haven't looked at my monthly electric bills, but as you can see, I'm producing more clean energy every single month than my house consumes. So yes, I have eliminated my monthly electric bill. It is zeroed out. Number two, am I sending clean energy back to the grid for others to use? Well, as we saw, I'm sending quite a bit of clean energy back to the grid. If you total the years 2021 and 2022, I've sent back more than 11 megawatt hours of clean energy back to the grid. So I would say that I'm accomplishing goal number two. And then goal number three was to have a whole home clean energy backup system. As you saw, I purchased a battery system for that. And we'll look more in depth into the battery in the next video. And that's what I want to talk about in my next video is how I manage my energy consumption. There's certain techniques that I use to manage my consumption and how I measure my consumption. And so we'll look at that in the next video. This is going to be very important. I think it's going to have something in there for everyone to use.